task is on a propane tank. So people who live in isolated areas have their own tanks of natural gas to run appliances like stoves and washers and water heaters. Those tanks are shaped like this, where you have a cylinder in the middle and then two hemispheres on the ends that would then make one sphere if they were connected. The Insane Propane Tank Company makes tanks with this shape in different sizes. The cylinder part of every tank is exactly 10 feet long, and you can see it labeled there. But the radius, R, will be different depending on the size of the tank. Now, they make a standard tank. So the company wanted to double the capacity of their standard tank. And a standard tank has a diameter of 6 feet. So let's make sure we understand that means the same as a radius of 3. And then the question is, what should the radius of the new tank be if they want to double the capacity? Well, another word for capacity is volume. And so we need to know the volume of the standard tank before we can double it. So how would I find the volume of a standard tank? So let's do it together. So we have a cylinder in the middle. How do you find the volume of a cylinder? And it's pi r squared h, and that can come from your reference sheet. And then you're going to add two hemispheres, or one sphere. And how do you find the volume of a sphere? Is 4/3 pi r cubed. So this formula then will give me the volume of that propane tank. For a standard tank then, we know the radius we just said was 3. The height of it is 10, that's in the middle. And then the sphere, again, would have a radius of 3. So then you would type that in your calculator and get an answer. So the approximate answer for the volume of that is 396 feet cubed of volume. Next, I want to double that. So I'm going to take that answer times 2. I want to know what would that volume be if you doubled it. So that answer is 792. So we want to know what the radius would be if the volume has been doubled. So we're going to go back to this beginning, but we're going to go 792. And we're going to write down, we don't know what the radius is. That is the variable we're solving for. The height is going to stay at 10. And now we have an equation to solve for. So I need to solve for r in this equation. So I'm going to have you solve this equation with your graphing calculator or with Desmos. Now, if your graphing calculator, you would go F1 algebra solve, and you would write down solve, and it would look like this, right, when you type it in. And you would type in 792. I would likely use X instead of R. Make sure you use parentheses around the 4/3. And again, pi x cubed. And make sure you go comma x, and then go Control Enter, and it would solve it. On Desmos, you'd have two equations you type in. So the first one, I would only have you type in y equals 792. And on the second one, you type in y equals, and again, I would use x. So pi x squared times 10 plus 4/3 pi x cubed. And in two different boxes. So box 1, box 2. And then you're going to have to zoom out, like zoom out, zoom out, zoom out on Desmos. Try it. And what you're looking for is the point of intersection on Desmos. So you're looking for where do these two cross, and it will be like in gray, the dot. So zoom out until you see it, click on it. So why not try? Like press pause and try on Desmos and see if you can get the same answer as me. And we're going to round it to a whole number. All right. So if you are on Desmos, I'm looking for the x coordinate only. So what's the x? I know the y is 792. What's the x coordinate approximately? So what should the radius be to double the capacity? And the answer was about 4. It was like 4.0 something. So the question was, what should the new radius of the new tank be? So the radius of the new tank should be 4 inches. Done. Awesome. That was it, right? Is there what? No question on the back. Nice and simple, right? Good little modeling question to do with that. Excellent. All right, Mr. G Math over and out. It's a quick little video for this. All of them should be this short, right? All right, till next time.